Alright, welcome back guys. Going to do a brief video on gas appliances and show you some of the controls and things that allow them to work safely. So here we have a pre-disassembled case of a basic flueless gas heater. A small one, but it's got quite a few interesting controls that we can look at and zoom in depth to see how it works. So first off, we've got ignition. This has got a piezo igniter. The actual piezo component is down here, and when we turn the knob, the striker hits a crystal that's in this black plastic part, creating a high voltage, about 6,000 volt current, which travels down this insulated wire to the ignition electrode, and then it jumps the gap to earth. And in this case lights the pilot. So let's turn it off again. So on the initial light up, gas flows to the pilot, the ODS pilot, which I'll explain a bit in a minute, and the main burner all at once. Some things will light the pilot first and then you'll turn it to the main burner, like a hot water cylinder. So I'll light it again. So when it's in this ignition stage, we're actually holding open the gas valve mechanically by pushing it open, and then provided that it lit successfully and the pilot, or the ODS pilot, heated this bit here, which is called a thermocouple, holding one as a pointer, it's going to create a small amount of voltage which is going to hold open the gas valve. So in the back of the unit where it connects in, there's an electromagnet which holds that gas valve open. Let's see if I can find it. Sorry. Basically, that's the gas valve, that's the thermocouple, and inside there's a copper winding, copper coil, which is an electromagnet. So when this gets hot, see if this one actually works, tighten it up a bit first. If we heat that up by putting it in the flame, when the gas valve's manually opened, let's actually see it stays open, so it's powering it now, so this one's a functional thermocouple. And then if we let it cool down, it's going to eventually cool down enough to pop out. We're still in the heat from the heater. Painfully slow here. There we are. So it cooled down to the point that it shut the gas valve off. So that's how it keeps the thing safe. So if the flame blew out accidentally, it would eventually cool down about 30 seconds or so, and the gas would be shut off, meaning that there's no unburnt gas escaping into the room, keeping it safe. So if we go back to this appliance, so also on that same circuit there's an over temp, looks like another thermocouple, but in this case, if this one gets hot, it will actually break the circuit. So instead of making power, it will cut the power. I think it just works on resistance, just builds up resistance, which stops the circuit. Also back in here in the back, on the same circuit, there's the tilt switch, this little device here. So what happens is, if the appliance tilts over, if I can do it now, tilts too far, that tilt switch will activate, which will cut the power to the thermocouple, which basically locks it out, turns it off. So it's a safety device. Over here we can see a different style of tilt switch, hard to see. So this is a mercury switch, which has got a clear glass bulb holding it. So basically when it's in normal operation, the mercury completes the circuit, and when it tilts over a certain angle, it breaks the circuit, which shuts the power off, which shuts the gas valve that we looked at previously. So that's a tilt switch, how it operates. So the other couple of things to look at here, get it going. Oops. Heat that thermocouple up a little bit more. So the other thing we've got here is what's called an ODS pilot, so oxygen depleting sensing pilot. So it's not like a sensor as such. You've got the normal thermocouple, and this pilot is designed so that it just sort of heats the top part of it in a controlled way, And if oxygen level in the room starts to reduce, it will change the shape of the pilot. So the pilot, instead of burning as it is at the moment, heating that thermocouple quite well, I probably can't get around the whole thing, but I can't get to the back side of the air thing. As oxygen level reduces, that flame will become yellow and floppy, and it will lift up away from the thermocouple, which will cause it to eventually turn off. So that's how it maintains a safe level of oxygen. So it doesn't actually, when the oxygen level drops, it's designed to shut it off as a safety thing. Burner wise, 2 burners. This is a ceramic, this one here. Basically the flame is burning just sort of on the face of that, or even slightly in those holes, and that gets super hot and then it radiates out heat. The injectors for the main burner come off here, so there's the injectors there, and at the back it's actually got aeration plates that you can adjust on this one. Most modern appliances have fixed amounts. So if we, for example, reduce the airflow to one of those burners, so the top one's got reduced airflow, you can't see a massive difference. But potentially that would have altered the flame picture somewhat. Probably not burning as well as it was before, but you can't really see it. Back as it was. Sometimes on a normal burner, a more standard burner, you'll see the flame go very yellow and lift off. See this one, you can't particularly see the flame, and you just sort of see the glowing incandescence from the ceramic, so it's a little bit different. Alright, so that was a brief overview. We'll look at a couple of other appliances. Yeah, we can stop that.